Hi, my name is Jacobo, and today I'm going to talk to you about what is overcurrent, overcurrent protection devices, sizing overcurrent protection, and disconnects. So, what is overcurrent? Overcurrent is a condition that is very dangerous and undesirable in a system. It occurs when there is higher than rated amperage flowing through the circuit. This higher than rated or higher than normal amperage flowing through the circuit can cause overheating of the wiring, the components, connections. It can lead to fires, it can lead to shock, it can lead to property damage and death. So because overcurrent can be such a threat to people and property, we must implement or integrate safety measures within the circuit. These safety measures are taken by adding components called overcurrent protection devices. So because overcurrent poses such a great threat to people and property, we must implement or integrate safety devices, more commonly known as overcurrent protection devices, which I will show you next. Overcurrent devices are classified into two categories, and the way they classify them is on how fast they react to high current. So here we have our two categories of current protection. We have our current limiting and we have our non-current limiting. I'm going to explain on how these operate. So here we have our normal current flowing through the circuit, cycling through. At this point here, our device opens because of a spike in the current due to a short or a problem in the circuit. What will happen is the current limiting device will opening up the circuit and not allowing this dangerous current to flow through and possibly causing damage to our components or wiring, homes, property, people. So the current limiting device reacts very, very fast, only allowing about a quarter of this overcurrent to go through. As opposed to our non-current limiting device, we can see here where the current is flowing through the circuit, the current spikes again, maybe due to a ground fault, short circuit. It allows more of this current to flow because it doesn't react as fast as our current limiting device, and so more of this high current is absorbed by the circuit, which I have here put in yellow with the red lines going through, and then it goes down on the down cycle. We can see here where it eventually opens up, and you can see the current here flowing through. But as you can see, it takes a lot longer with the non-current limiting device, and causing a lot more damage to the components and wiring. So here we have some overcurrent protection devices. This is your old school screw-in fuse that you would see on a plug or in some of the older main panels. You don't see those very much anymore, and now code requires you to replace them. Here is a 20 amp dual element fuse with some adapters. Here's a 25 amp. Here we have a 30 amp. And once you go past 30, they change in size. As you can see, this one is a lot bigger than the 30 amp. This is a 40 amp. Here's another 40 amp. This is a 100 amp. And something curious, this one is way bigger than those two, but this is only a 15 amp. The reason they get away with that is because this came off of a three-phase system, where you can go with less amperage, and so we have three fuses with 15 amps on them. Here we have this is a single breaker. This is what you would normally power up your plugs in your home or your lights. Basically, this part here catches on the electrical box. There's a thing that catches on here, and this part stabs in to the bus bar. Here we have a quad where we have these 30 amps on the outside, and as you can see, they're linked by this. This is for things like your electrical dryer, your air conditioning systems, things that use 240 volt, 220 volts. Here's a 20 amp. What's nice about these is that they save space within the electrical panel. So these are a lifesaver sometimes. Here is a dual 30 amp, and again, this is non-metallic, but it's plastic. But if for some reason, let's say a winding of a motor or the short on this bus bar or on this side of the circuit would trip, it would actually shut off the whole device or component that we're running, such as a motor, air conditioning, dryer, whatever. So that's a 30 amp. Here we have a 20 amp breaker, and here's a big 70 amp Censko breaker. They don't make anymore. This one is damaged, so there's a manufacturer called Sylvan who makes a replacement for this. Okay, so a little more in-depth information on these current protection devices. This is a fuse. Inside there's a element or a metal link which, when it experiences an overcurrent, it heats up, opens up, cuts the power, protecting our conductors, equipment, and so on. This here is a dual element. I don't know if you can read it or see it, but it's a dual element. This guy, as opposed to just a single time fuse, will take a beating. So these guys are tougher. This is mostly used on motors, things that pull a lot of amperage, and they will take a beating, and that is the difference between a single and a dual time delay fuse. This here is a breaker. It also has a metal inside element that senses temperature. These are normally known as thermally protected devices because they sense temperature, and upon that temperature they will trip and protect the device or components, conductors within the circuit. So overcurrent protection devices must be integrated properly. You can't just put any size breaker or fuse into a circuit without knowing some information first. So after you have calculated your maximum circuit current from the short circuit current of your panels, you add another 125% to get the size of your overcurrent protection device. So let me show you an example of how to properly size your overcurrent protection device. This is an example I got from the book, and what it's telling us is that if we had a 3-source circuit and each circuit had 7 amps, we would multiply the 7 amps by the circuit. We would have 21 amps. We multiply that by 125%, and our maximum current would be 26.25. Now, to get our overcurrent protection, what we do is we multiply our 26.25 by 125%, or we add 125%, which will have 32.8 amps. Now, since they don't make fuses or breakers, 32, they only make them in 25s, 30, 35s. We couldn't go with a 30 because we would be under, so we would have to go with the 35 amp fuse. Okay, that concludes our section on what is overcurrent, overcurrent protection devices, sizing of overcurrent protection devices, and I want to touch a little bit on what disconnects are. There are different types of disconnects. There are AC disconnects and DC disconnects. This is an AC disconnect. Disconnects are very important in circuits because what they do is they isolate the circuit for the purpose of performing maintenance and repairs to the system. Let me give you a closer look of what this disconnect box looks like. If you could just get a little closer. We have a disconnect pullout. In order to get into this or pull this cover off, you can see that the cover will not come off unless you pull the disconnect out. This disconnect allows current to flow through the box from the line voltage to the load side, and I'll show you that in just a minute. So for the safety of the repairman, troubleshooter, maintenance, you pull this off. That isolates the circuit, cuts power from the line to the load. Now you can take this cover off. If you look at this cover, This particular box is a 60 amp box, 240 volts, single phase, and it is a 2-wire. So when we look inside here, if you could take a closer look, you will see that it says line right there. This is where your source circuit wires will go. This is where your power wires would go. And so let's say you have an array. Let's just say the wires going to here. You will have fuses in here, like so, and these can snap in. Here's a fuse with some adapters. Okay, and so now we have a flow of electricity. We would have a flow of electricity from our line to our load terminals, which are down here. So this would go, down to our distribution box. But it will not flow without this disconnect. So you pull this disconnect out, and it cuts the voltage from the line to the load, making it safe. Or anything down on this side, on the load side, would be safe if you didn't have, another source like batteries or whatever. So let me just give you a little example of how you would test these fuses. This particular meter here, field piece meter, has a continuity tester, and a continuity tester will show us, or will help us troubleshoot a fuse. As you can see, if we go to either end of this fuse, our meter is telling us that we have continuity. We can also ohm the fuse out, check the resistance, and we have a resistance of around 1. You wouldn't want a high resistance because then it would become a load, possible voltage drop. So here's the reading. I like using the continuity. Gives me a visual and an audio. And you can quickly tell that the fuse is okay. Now you could also test the fuse while it has power, and the way you would do that is you put it on volts, and when you went across the fuse, you would read 0, meaning that you have a closed circuit. But if the fuse was open and you went across here, let's say this is 120 running through here, you would read 120 volts. These boxes are secured to the wall by these holes, and then you have your knockouts here on the bottoms and on the sides where your conduit would come in. You have them also on the back, so if you put it on the wall, your wire could be coming through the hole here into the box, and you would hook it up to your terminals, and then you would have your conduit seal tight, EMT rigid would be coming out to your equipment or to whatever you needed to your loads. So this is very important because this protects your fuses from the elements, from the weather. You definitely do not want any water on these fuses. While there's power on there, that would be very dangerous. So these fuses, or these disconnect boxes, are very important to the system, to the electrical system. This is one particular box. There's also boxes with levers on them. You would see a lever here that you would clearly say on. If you went up, it would say off if you put it down. On some of them, you can't even open the door unless it's on the off position, and that is for your protection. So, my friends, that concludes my video. Hopefully, this is helpful to you, and you can learn from it as much as I have learned from it. Thank you.